Hello friends, now we will talk about OTV. I must tell you that it is one of the most important topics and it is asked in every interview because it deals with connecting data centers. So what is the full form of OTV? It is overlay transport virtualization. That is your you have to encapsulate your layer 2 traffic over the layer 3 link, which is basically there between the data centers and extend the VLANs or extend the LAN. So let me take you to presentation wherein I'll show you by diagram. Okay, so let's say that this is your nexus 1, nexus 2, and here is your server connected. Okay, so this is the main nexus 7K switch. Okay, so let's assume that this server is on VLAN 90. Okay, and there is one more DC with similar number of devices, and it also has VLAN 90. But if these data centers are separated using L3, that is any IP3 connectivity, then you will not be able to extend this VLAN 90 over this. Or you can say that this you can say that the broadcast will not forward for VLAN 90 over to DC2. So it is DC2, it is data center 1, that is DC1. So if you want to extend the VLANs or you want to connect the LANs, okay, or you want to span the VLANs, you have to use OTV. So what will happen that will configure this feature on the edge devices, this and this, and will form a kind of tunnel, and after that these two DCs will appear as a single DC. That is the main purpose. Sorry for the wrong means the bad handwriting, but my purpose is just to tell you that OTV is used for connecting the LANs which are separated by layer 3 network. Okay, it can be any transport, it can be MPLS, it can be internet, it can be point to point. Okay, so even if you have a layer 2 tunneling protocol being used, you can still you just need to have a layer 3 connectivity between the data centers, and you should have the capable devices which are able to handle OTV. So after that you will be able to connect these data centers. So this is the overall high level diagram. Let me take you to the presentation part. So it is basically layer 2 DCI, that is data center interconnect. It is used for connecting data centers. You can also call it as a layer 2 VPN over IPv4 or over IPv6 in case you are using IPv6. Okay, so even if you have point-to-point network, MPLS network, internet, or GRE, whatever kind of transport, it will work over it. Okay, it just needs layer 3 connectivity. That's it. You can have more than 2 data centers as well. Okay, like I said, the minimum requirement is that layer 3 reachability is there between the DCs. So once it is configured, it will appear as if these data centers are a part of just a single data centers and LANs are connected. So what happens? Let me give you one typical scenario. I'm gonna clear this dirty diagram. What happens that probably you've heard the word ESX. Let's say that it's a big ESX box present in DC1, and here is another ESX in DC2. We know that we create virtual machines like VMs. So one ESX can have any number of VMs, depends upon the capacity and license. Let's say that you have 20 virtual machines here and 10 here. Okay, These are having VLAN 90 on both ends. However, these are in geographically different locations separated by layer 3. So in case there is an issue with this ESX, in that case, if there is no OTV or if there is no DCI, then you will not be able to move these 20 VMs to this ESX, okay, because these are separated by L3. So once we use OTV, these both devices will become part of a single LAN. So it will be a single LAN. After that, you will be able to move these virtual machines transparently without any outage. Means users will have no impact. So so this OTV will come into rescue. Okay, so if you have this kind of setup, your problems will be resolved, because there can be hardware level issue, there can be a network level issue, or some kind of physical issue. Okay, CPU, high memory, network errors. So instead of creating outage, you better move these devices to another data center over the same LAN using OTV. So it is the main benefit of this wonderful feature. Okay, so let's talk further about it. There are actually many ways to connect LANs apart from OTV, because it is a feature mostly being used on Nexus devices and on ASR 1000 series routers. Okay, its port may be extended on multiple devices, but till now these are the two that I am aware of. Okay, so earlier we used to have dark fibers. In fact, we still have. It's very expensive solution. So herein there are two types, CWDM, DWDM. So actually in fiber, what happens that we use single mode fiber for long distance and multi mode for short distance. So it is basically a point to point dedicated circuit. Okay, so this is one of the solutions, one of the DCI that is available. Then there's L2TPv3, that is layer 2 tunneling protocol of version 3. It is not MPLS dependent. If you have internet, you can form this L2TPv3 tunnel, and it basically requires an IP connectivity. That's it. So then there is an Atom, that is any transport over MPLS. So but like it says over MPLS, you need to have MPLS infrastructure in place in order to use this TCI. Okay, it's basically point to point MPLS layer 2 VPN. Then there's a VPLS. It is also MPLS dependent. And the only difference between Atom and VPLS is that it's a point to multi-point. Okay, so these are all DCIs available, but the good thing about OTV is that you just need to have a layer 3 connectivity. It doesn't depend only on MPLS or point to point. Any kind of transport can be used in this. What are the benefits of OTV? It basically doesn't allow the flooding of spanning tree. It means that each DC will have its own spanning tree domain. Okay, so it is a kind of demarcation point. So every edge OTV device will be demarcation. So flooding will not happen of spanning tree. It will basically reduce the amount of unnecessary traffic sometime. I'll also talk about the terminologies which we use in OTV. Don't worry about it. As of now, these are just benefits that we need to understand. It doesn't allow or doesn't forward the flooding of ARP request reply or ICMP v6 neighbor discovery messages. What happens that if you allow the ARP request or reply messages to travel over the OTV tunnel, okay, actually I mean to say that these messages flooding is not allowed to cross over the OTV tunnel. Actually we will form a OTV tunnel, so once it is formed, these things will not be allowed. It's basically a loop prevention, or you can say control method. So our request reply will not be forwarded. ICMP v6 neighbor discovery messages, which is basically part of IPv6, these won't be forwarded. Actually, we have proxy ARP cache that is created on the edge devices. We'll talk about it later on. It limits the failure of broadcast domain because flooding is not forwarded. Spanning tree domain is demarcated on the edge device of every DC. So terminology: edge device, the device which is running OTV feature set is known as edge device. I told you Nexus devices and ASR 1000 series router are capable of running OTV, and it is known as edge device. So AED basically it is also an edge device, but the device which is an active forwarder of any VLAN is known as AED, that is authoritative edge device. Once we do practical lab of it, then these things will be clear to you. If you have multiple AED, in that case there would be election. Okay, so one AED will forward traffic of one VLAN and other AED will forward traffic of other VLAN. So how does it come to know which VLAN traffic has to be forwarded by which AED? Actually, it uses the load balancing concept of odd and even. For even VLANs, one AED will forward, and for odd VLANs, other one. Okay, but it is basically, it cannot be changed. The order cannot be changed. We cannot change this load balancing mechanism because it is a way it has been designed. So let's say that only even VLANs are sending and receiving data. In that case you would say that it is not a good load balancing mechanism. However, it is the way it is, and it helps in loop prevention as well, because one VLAN traffic will only be sent by particular AED, it cannot be sent by other AED. So this is the way it helps in loop prevention. Extend VLAN, the VLAN which will be extended, like in diagram I told you VLAN 90, so that will be extended VLAN, the VLAN which will be extended over the OTV tunnel because we are connecting the data centers. Side VLAN, the local VLAN, it is internal VLAN used for electing the AED, authoritative edge devices. So if you have multiple AEDs, then it will be used for synchronizing the control plane information. Okay, site identifier, it is a unique per DC. Note that it is unique per DC. So if you have more than one AED, that is authoritative edge device, then all of the AEDs should have same site identifier. Okay, it helps in loop prevention. So if you have 3 devices in your DC, all 3 should have same site identifier number. However, this will be a unique ID per DC. If there are 5 DCs, so every DC will have unique ID. Okay, overlay interface, the logical interface or OTV tunnel. Like let me take you to this diagram. So once these DCs are connected, so this will be known as OTV interface. Okay, or OTV tunnel. Okay, overlay interface, OTV join interface, the actual physical link, this one. Let me change the color now. If this is the physical interface, it will be OTV join interface. Okay, physical interface. And also note that it cannot be SVI, it is not supported. It has to be native L3 routed, or you can use layer 3 port channel. Okay, layer 3 port channel, only these two are allowed at this moment. So SVIs cannot be used. It may be used in future operating system upgrades. However, it is not allowed right now. Okay, so overlay interface is the logical tunnel, OTV join interface is the physical interface on the devices. So it will be the one which will send upstream data towards DCI. So this is about the terminology of the OTV, and let me tell you a few more important points here. Okay, in OTV, once you configure it, ISIS will be used. Like in Fabric Path, I told you that OTV and ISIS, OTV and Fabric Path both use ISIS uh, for uh, for forming the neighborship, or you can say forming a tree. So this is the routing protocol which will be used. In the good thing is that we don't have to specifically enable it. The moment we configure OTV, it will be enabled. Okay. Other point is that the MAC addresses will be advertised. If you remember in Fabric Path, I told you that MAC addresses will not be advertised in Fabric Path because those are learned using conversational MAC learning. But in OTV, MAC addresses are advertised. The benefit that we get is that the edge devices will have control which MAC address to be forwarded to forwarded over the OTV tunnel. Let's say that this is DC1, this is this DC2. If there are 8 MAC addresses, so we can restrict any MAC address on DC1. So this is a kind of distribution list. Okay, so we can prevent any MAC address to travel over OTV tunnel. So this is a good thing about this MAC advertisement, because it gives us an extra control when we configure the OTV. So main points is that we need to understand the AED, that is authoritative edge device. Let me write it cleanly. This term we have to understand. Also note that we need to know little bit of multicasting. Okay, because we know that multicast is a very good method of delivering the video, generally video traffic. However, unicast can be used as well, but unicast, you know that it is not that efficient. So in case you don't know about the multicasting, just learn the 2-3 commands, because our purpose is just to enable OTV and see this functionality. However, I suggest that you go through the multicasting lectures as well if you find anywhere, or you can just refer the Cisco site. You'll be able to find some terminologies on multicast like sparse dense mode, dense mode, SSM, source specific multicast. Okay, SNG group. So in the next lecture, I'll do a lab on it. So in that lab, lot of things will be cleared, and after that it will become very easy for you to configure and operate OTV. And one most important thing I forgot to tell you about OTV is that the moment you use it in any VDC, then make sure that SVI interfaces are not configured in that VDC. It is very weird restriction. Let me clean it now. Let's say that there are 4 VDCs of any physical box. Here you are using OTV, then you cannot use SVI interfaces on this VDC. Okay, so that would mean that your features like HSRP, GLBP, VRRP will not work here. You have to use other devices for these HSRP, VRRP and SVI interfaces. This thing is very sometimes frustrating, that OTV will eat the complete VDC. Okay, so you have to understand it. Also, it has a separate license In case you don't have it, use the grace period. However, it is recommended that you use a separate license for it and then enable the feature. So anyways, I'll also upload a file which will have all of the important points covered, so you can read that. It will be very easy for you to understand in case you've not understood by this video. However, I suggest that you watch these videos 2-3 times because this is a new topic. I hope that it's been informative to you. Thank you.